Hello there, ladies and gentlemen, and welcome to another video. Now, this is probably going to be the last one for developing this router, because it's pretty much done. I just need to fix up the Windows thing here. So just to make sure that everything still works, I'm going to compile it for Windows with this thing. Yeah, seems to work, and then I can do router exe vv. Okay, so we found oh yeah, I need to plug in my actual fucking trackball, hang on. Okay, got it plugged in, so let's run this thing again. Yeah, there we go, we found 3 devices. And if I try to scroll with the trackball, it works. And then you see the packet here as well, which got received. Then if we were to increase the DPI, we can increase it here like so, then decrease it and set it back to default. Okay, cool. So yeah, everything works just fine. However, the only thing that I don't like is this is quite big. So, like, realistically, all that we're doing is we are adding a buffer here. Yeah, so we're creating a buffer here. We're adding 0. And, oh yeah, actually, what the fuck is this? Yes, actually, we are doing what we're supposed to be doing. Yeah, so there's some bullshit going on here, which is fine. So yeah, I'm going to get rid of all of this crap because we shouldn't need to. So we have a buffer here that is 1 byte bigger than our total size, because that's how you actually need to do this in dumbass Windows. And what we want to do is we want to squash this thing down, and we can probably do packet like this. So yeah, and then we can just copy the buffer like so. But yeah, I suppose that's it really. I'm pretty sure that this will work. Yeah, that works. Okay, good video, but yeah. What I want to do is see if there's like a good way to do this sort of thing. By just copying the raw memory from this straight into the buffer. Yeah, so let us look for that. So C copy memory to buffer with offset like so. Yeah, copy memory starting from maybe not this. As the destination. Yeah, I'm not sure that this will work kind of in our case. Yeah, let's see this thing. So I'm just gonna copy this straight in. Any way to improve this with mem cpy. Yeah, this is what I thought that we could do. Yeah, and then we just copy this much, so we don't even need squash, so you can just pass in. Okay, that's pretty cool that you can just pass it in like that. I didn't know that you can just do that, which is cool. So, yeah, we'll leave this thing as here, as buffer. We will try to get rid of this thing. So, and we'll try to get rid of this thing as well. So then, what we do is memcpy. Then we take the first address of buffer, because we don't want to copy it into the first one. We want to copy it into the second one. And then what we're going to do is going to do packet. Then we're going to do raw heap size like so. And in theory, that should work. It might complain about this being something weird, but yeah, in theory, this should work. So let's give it a try. It compiles, it runs, and it works. Excellent. So yeah, that's a nice way of doing it. Okay. Yeah, so that's all working. Can decrease it. Let's head back to default. Okay, cool. All right. So yeah, that was a fairly quick change. Yeah, so that's kind of it. That's kind of what I wanted to do for Windows. So yeah, that's cool that you can do this shit. So anyway, yeah, the rest is kind of fine. Yeah. So I suppose another thing that we can do is this delay thingy. So by default, this is not, being passed in. So yeah, so here we have it refreshing at 200 milliseconds. We can actually leave that as is for now. And inside here we can do, let's see actually, what even does this thing put in, or what do you even use for this thing? Okay, so it's a D word. You sleep. C Linux you sleep. Where's this function? Okay, so it takes seconds t. What the fuck is seconds t? I wonder, can I just fucking put in like, because this thing takes D word. Yeah. D word. Okay. So let's ask the AI. If Windows uses the word for sleep, what Linux uses seconds t for you sleep? What type should I use for both of them? Then uint 16t. Let's see. Which is okay, so it's a 32-bit unsigned, which is typically okay. So it's just 32-bit unsigned. Yeah, so we'll just do uint 32. Yeah, that's fine. Yeah. All right. good enough for me. So let's give that a go. Here I'm gonna put in yeah, extern uint at 32t, and then this will just be see, sleep duration, like so. And then this will go inside the protocol here. Yeah, so it'll be defined here. Yeah, and this, where the fuck is the C function? Okay, yeah, this includes that thing as well. So that should be fine. So what we will do is, yeah, so where we have all this stuff, first of all, we will define this to be, where is it? Yeah, this thing. Oh yeah, sure. That means we also need to, wait, delay between loop. That's what we want to do. Yeah. So we're actually running this at 100 milliseconds. Okay. So it'll be like this. Yeah, the thing is here, like refresh device interval. So be inside here. Yeah, so this interval will kind of fuck up a little bit as well. Or yeah. So I have an infinite loop. How do I trigger a function to run every 20 seconds? Have an infinite loop with variables sleep time from, let's say, like 100 ms to 500 ms. How do I trigger a function to run roughly every 20 seconds on both Windows and Linux? Let's see what this guy comes up with. Okay, elapsed time. Okay. Yeah, that is fine. Okay, so it takes account into that. Trigger interval. 20 seconds in milliseconds. Okay, do you know what? That's a cool way to do it actually. So it doesn't really use the OS, which I was like, you know, the actual fucking time, but yeah. So yeah, lapse time, he's just adding up the sleep time, which is fine. You know, that's all right. So that's what we'll do here as well. So we'll do uint, we'll probably, yeah, we'll do uint 64t maybe. Oh no, actually we'll just do uint 32t. So uint 32t. Sleep elapsed equals 0. Right, then here, where we do this thing, refresh. What is this refresh thing? Okay, yeah, refresh is, yeah, actually we can put this thing inside here. That's kind of similar to what this thing is doing, but we wanna do something like this as well. Trigger time, so we'll refresh every 20 seconds, so that will be fine. We will start off at 10 seconds though, just so that we don't need to wait too long. And actually, you know what, 10 seconds is fine overall. since you don't need to wait for this thing. All right, so here, if what do we do? So yeah, after we sleep, we actually need to use a different thing here. So this will be sleep duration, and here sleep duration, and here then we need to do elapsed time plus equal sleep duration, like so. Identifier, what do you mean? What did I call this thing? Oh, sleep elapsed. Fuck's sake. Okay, so if sleep elapsed is greater or equal to trigger interval, then we do this thing, and we also put elapsed or sleep, Jesus, no, sleep elapsed to 0, so we kind of reset it. And that should be fine. What the hell happened here? Okay, yeah, that should be fine now. Now we just need to, inside the main function, we just need to add an option for this thing. Okay, so, oof, this is gonna be kind of interesting. So yeah, so it's gonna be strcmp argvi, and we're gonna check for say, what will we check? We'll check for t, maybe. Yeah, or. Yeah, maybe or, I don't know. We'll check for one of those. So if this equals 0, all we want to do is we want to do I++, so that way we advance this loop, and then what we want to do is we want to get the number from it. So get sleep duration. All right, so we'll just copy all this shit into this bad boy. See what he says. Jesus, okay. Oh, okay, so he just uses A to I. Okay, all right. Yeah, so this is in milliseconds anyway. So yeah, that's fine. All right. That looks good. Yeah, so he even checks if we're not overflowing, so that's pretty good. All right, so let's get rid of these comments so it looks like I'm not using ChatGPT. All right. So yeah, this is like, I don't know, refresh rate or something, I don't know. Anyway, let's print it. So, R then let's just do like 100. How often to run the loop? 100 means every 100 milliseconds, like so. Okay. Yeah, that is fine. Yeah, because that's by default anyway, so we could run it lower. All right, let's give this a try. Let's compile this bad boy. All right, and first of all, let's see if it refreshes after 10 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. So yeah, it does refresh after 10 seconds. Now let's try the rate. So if I set this rate to something really high, like 10,000, that means this should, or actually just 1,000 will be enough. This means it will refresh the devices only once per second, so there should be a good bit of lag. So yeah, running it now. And yeah, I can feel the lag. Yeah. So if I'm gonna press the increase DPI right now, and yeah, you can see the lag. Yeah, so the lag is pretty high. So that's good. Now, let's open up Task Manager. And what is this shit called? Well, actually, it's not running, so yeah, first of all, let's just do it like this. Now, this should be QMK or something like that. Yeah, QMK, HID router. Okay, so here we go. We have our program here. And right now it's using no CPUs. Well, just barely any. Yeah, and it's using 500, or it's using 0.5 megabytes of RAM, and it actually gets suspended once in a while. The fuck? Okay, anyway. Right, because yeah, it's kind of like, you know, sleeping too much. But now, if we run it at the default, which is 100, it's, you know, responsive and everything. So yeah, very good. It's still using 0% CPU, which is good, how it should be. Yeah, all right. And then if we were to change this to something mad like 10, so now it's like very snappy. Yeah, very snappy. It's still using 0% CPU. Huh, interesting. Okay. All right, let's change it to 1 millisecond. All right, so now it's reading everything like mad, but it's still 0% CPU. Yeah, that's pretty good. That is pretty good indeed. Holy moly. So do you know what? Do you know what? To make it, you know, more snappy, let's put this down to 10 milliseconds by default. Yeah. Okay, so this refresh device interval, I'm not sure if I use it anymore. Yeah, I don't use this thing anymore anywhere in the code. Yeah, nowhere in the code, so yeah, this can be deleted. Yeah, and that's about it. Yeah, that's pretty good. So yeah, we changed that to be 10 milliseconds. And yeah, and then we added this thing to check if it's to pass in your own. So I guess you can pass in like whatever. Okay, so we can delete this thing. Get the fuck out of here, my boy. And now, I'm pretty sure I wrote something like 100. No, I didn't. Okay. Right. So since this thing's like light and efficient, we should actually fucking put that in the in here somewhere. Yeah, it is very efficient using 0% CPU and 0.5 MB RAM. Okay, yeah, so that's good. We put that in there. Right. So there was a usage page somewhere. Oh, I actually don't have any settings page, I don't think. Oh no, I do. There we go, running. Yeah, we'll do 10 seconds. Because 20 seconds is, you know, maybe a bit too long. Yeah, because if I were to refresh the devices, now that I think about it actually, well, let's actually recompile this thing. Yeah, I never tried this before. So I'm running it right now. I'm scrolling, and I'm gonna keep scrolling for like 10 seconds. After the device refreshes and see what happens. In theory, since this is kind of stateless, it shouldn't matter. Okay, so he refreshed the devices and I'm still scrolling, and if I let go, yeah, so that's still good. Yeah, okay. So yeah, it works as you expect. So yeah, that's fine. Yeah. Okay. Yeah. So you can change the latency by running or 1. Yeah. So in this case, this will set the latency to 1 millisecond, which still doesn't have any load on the CPU. 10 milliseconds is the default, which, yeah, it is 10, right? Forgot already. Yeah, it is 10. Yeah, because we set it here, delay between loop. Okay, cool. So yeah, which is more than enough, but if you want it faster, can just set it as 1 and it will be fine. All right, that's good. Now let's see how this H looks like. Yeah, that looks fine. I suppose we should actually put default like 10. Because yeah, let's do that here. Then we'll do default 10. Yeah. So, oh shit, we were to compile this bad boy again. Yeah. Yeah, all right. So that looks fine. Cool. Let's see if show still works. Yeah, still works. Good. Okay. So yeah, this is pretty much it. I like that we carried out this test and that it doesn't use any doesn't use any CPU, which is fucking funny actually, considering like, you know, all the other bullshit software that you have on your PC. Like, this is fucking sick. 500 kilobytes is still kind of a lot for considering what we're doing, but I'm pretty sure most of that is just the library. Um, it's just this library thing. We can actually go into resource value or no, not properties. There's like another thing that you can do. Details, I think. No. Yeah. So 508 KB. But um no, not that. There is like, let's see, process. I'm pretty sure I have this installed. Hang on. let me find it. I know I have it installed, just don't fucking remember the name. Process Explorer, I think it's called. Process. Okay, for some reason it doesn't come up here. But that's fine. Is it this one? Oh yeah, it is, yeah. Great. So, why is it transparent? The fuck? And you filter process. What we want to do is find QMK raw HID. What the heck? HID. There he is. Alright, so this gives a bit more info. So it even has the command line here. Oh yeah, cool. Yeah, is there a way to... No, not this. Actually, I think there is another one. I don't think it's actually Process Explorer. It used to be called... I think it's called System Informer or something like that. System Inf... Yeah, I think it's this one actually. Oh yeah, there it is. Yeah. Okay. I don't know what the heck this is. Process Explorer. Just some random shit on my PC. Anyway, let's download an update. Cool. Check. Download. Cool. Epic shit. Anyway. So QMK HID. Okay. So in here, you can actually do other stuff. Yeah. So we can take a look at what is going on, like actually beneath the hood. So yeah, this is currently using 0% CPU, which is fucking funny. Memory, it went up for some reason. Virtual size 4 KB. Oh yeah, it's going up. Huh, we might have a memory leak. if it keeps on going up, I think we might have actually a memory leak with the refresh devices maybe. But I will keep on going, sure. If it goes up higher than megabyte, then I'll check it out. Alright, so your performance is fine. Yeah, but yeah, you can see that it goes up slightly. So that's not great, but we'll see how it is. So there's only one thread. Not sure what this is, but I think that's just some shit. Now, modules, here we go. So what is this thing actually using? Okay. Jesus. Fucking Windows. Anyway, yeah, so here's the yeah, here it is. HID DLL. That's only 180 kilobytes, so that's pretty good. Then it's using Microsoft C runtime library for some reason. And then it's using configuration manager DLL, whatever the fuck that is. So this is all like, oh yeah, here's the actual HID DLL. So it's using Windows for this thing. Okay, so I think we do have a memory leak somewhere because it is going up, and I think it's inside these refresh devices. Okay, so what we can do is actually accelerate this memory leak in a second. Okay, so we can see the memory here. Yeah, this doesn't help us too much though. Environment handles, yeah, all good. And then obviously nothing in the network. Okay, yeah, so leave this here actually. Yeah, so this thing seems to be more accurate anyway, so we'll get rid of that. Yeah, so we have risen over 1.5 megabytes now. So, actually, let's just leave this here. Yeah, so yeah, it looks like we have a memory leak somewhere. Alright, time to fucking find this memory leak. Right, so let's speed up the memory leak by setting the trigger interval to every 1 second. Actually, 500 milliseconds. Let's do 1 second. Yeah, that's fine. So we'll compile this thing, and then we will run it at this speed. Oh yeah, actually, let's do BV. Okay, so should refresh the devices every 1 second. Trigger interval. Yeah. Huh. I don't think this compiled. This should be every 1 second, so yeah, sleep elapsed 0. Okay, let's compile it again, just in case. Now let's run it. Huh, this is weird. Why is it not every 1 second? What the fuck? Okay, do you know what? Let's make this like this. Yeah, okay, there we go. So now, yeah. So as you can see, this thing is growing. Yeah, it is growing each time we refresh the device. So that's no good. Yeah. So this tells me that yeah, when we refresh this thing, yeah, we free the path. Mem set 0. Then we find the devices. Okay. Actually, when we find the devices, or actually, let us printf this thing. So, printf %d see how many devices are allocated, and then this will be this, like so. Okay, let's try compile this and see what is going on here. 666. Okay, so that doesn't change. Okay. So yeah, what aren't we doing? So I think I have a function here that actually clears stuff as well. The utilities cleanup, yeah. Okay, so we free the path, we close the handle. Okay, we could do that. So yeah, we free the path, we close the handle, that's fine. And I wonder, yeah, I mean, this technically should work. Memset devs 0. Yeah, I wonder what's not freeing. Let's see, what is, let's see, find devices. HID enumerate. It could actually be something to do with this. Let's actually print this as well. Let's see if we are hitting that thing too. Okay, this is kind of interesting. Did not expect to be doing this. Okay, so exceed the capacity. Okay. So yeah, nothing here, but it just keeps on going up. Okay, so that's fine. This is working as expected. Yeah, so we malloc the path, which we free later on. So that's fine. Yeah, handle we open. HID set non-blocking. We realloc here, which is fine. Then we free the thing. So okay. Okay. Let's try something like this for now. So instead of this thing, what we will do is we will free devs, and then we will do this thing. Now this should be fine. Yeah, let's see. Like it should still work, is what I mean. All right, let's see this thing. Okay. No, it's still going up. Interesting. So it must be something with the library then. Okay. Yeah, so if we don't find any new devices. Oh no, it still goes up. What the fuck? Why is it still going up? What the hell? If devs I handle. Actually, yeah. Let's actually see. Print f trying to read something. Like so. Okay. So it stopped trying to read something. And now it's not going up anymore. What the hell? I'm very confused. So this wasn't here before. And if I were to compile this thing. Okay, well, it's behaving now. What the fuck? Okay. But yeah, anyway, that thing did work as expected, because if I scroll up here, well, fuck it, I can't scroll up. Okay. So yeah, this isn't the problem. Yeah, so I'm guessing it's literally just find devices that's the issue. For some reason. Yeah. Okay. Interesting. Yeah, because here we are setting it like by itself. I wonder, what if I did free devs I, even though they're technically not really allocated with parameter of type void. What if I did this, or not this, I mean. Okay, I'm not sure that this is even going to work, but let's see how it goes. Wait, what happened? Oh yeah, because the first one is actually the pointer. Yeah, okay. Then just died. Excellent. Okay, so that doesn't fucking work. Yeah, okay. Oh wait, why is it dying now? What the fuck? Why is it just dying all of a sudden now? I'm so confused. Okay, it's back now. Okay. Yeah, we should actually do something like this. And this. Fuck. Shit. How do you do this in Windows? uh, okay. Let's see. How to do in Windows CMD. What? What the fuck? That's what I did. It's not a valued statement separator in this version. What the fuck? Actually, how to do it in PowerShell? Because yeah, we're actually doing PowerShell. Okay, so it's just this thing. Okay, so yeah, that'll be better for us. Okay, so yeah, it's still going up. Okay, so in this case, I am fairly certain that this stuff worked before. So what we want to do is we want to find these devices. I wonder, what if I didn't allocate anything? If I just said break, would that still do some bullshit? Let's try it. No, it doesn't. Look at that. Oh wait, it does. Wait, let's see if it stabilizes. 7, 8. Okay, so it's staying at 8. Yeah, it's dropping between 7 and 8. Okay, so that's good. Shit. Wait, what is going on? Got locked out. Okay, so let's verify that this isn't the problem what we're doing here. So let's comment all this shit out. Let's put this thing here. Yeah, so this is all new stuff. This is the print stuff. That's fine. Okay, let's try and do that. So C788. Okay, so that's good. So that means our old code is fine. It's just something inside the actual loop here. So, okay, so if it's not this thing, it has to do something with this path. But why though? Yeah, because we do free the path here. Yeah, we do free the path, so that shouldn't be an issue. I wonder actually. Yeah, so we copy the path here. I wonder, is it really just this thing? Cause oh yeah, we also need to, oh yeah, shit. Yeah, that ain't gonna work. Yeah, I'm pretty sure something to do with this. But let's give it a, what the heck is this? Oh yeah, we don't need this anymore anyway. Okay, but let's not open the handle. Do you know what? I wonder. What if... Yeah, do we really need the path in this thing? Well, we do for printing, but apart from that, we don't really. But anyway, Let's just do this for now, and we will open the path using the current device. So for dev path, like so. I think that should be fine then. It might just be a little bit fucked, but let's see. Okay, so it's still working. No, it's still going up though. Fuck. Okay, interesting. Huh. Okay, let's try this. So we don't set the handle at all. No, it's still going up. Okay. Interesting. I wonder. Actually, I wonder, is it running in... No, it shouldn't be. Yeah, that doesn't make sense. Actually, let's go into this thing here. Let's see how they finish it off. Okay, so HID exit. No, we don't need that. HID close handle. Okay. So yeah, we do that though. We do the free enumeration. HID enumerate. We were to search for that. We only use it here inside find devices. Okay. Yeah, so we don't really do anything here to see. I wonder if I were to comment out all of this thing, then let's see. Okay, well, this time it just died. Well, yeah, that makes sense. Let us increase. What the fuck? Wait, is it here? Oh yeah, let us increase this to 3 temporarily and see what happens. Okay. It's still going up. Okay. Yeah. So it's nothing to do with this. I wonder. I wonder how many times has he used this thing? 3 times, okay. Oh, well, no, just once. Fuck's sake. Yeah, I don't really get what could actually cause it now, because, yeah. Like, I'm not setting anything, not allocating anything here. Hmm. Yeah, because all we're doing here is reading. And we're not even getting a packet, so, yeah. If it's greater than 0, then we handle packet. But when we handle packet, we print it straight away anyway, so the code is not even going in here. Uh, yeah, I feel like HID enumerate is the problem. Because I don't really see anything else. Let me search for HID enumerate. Do you know what? That could be the problem. Fucking Windows. um, I wonder. Could I um yeah, let's see how this thing is actually implemented in the code. So let's see if we can find it here. Probably source. CMake, no. Yeah, let's actually clone this whole thing. So yeah, so git clone depth 1 this thing. Okay. So now we have it here. We can actually open it. Called FIDAP. We can open it in its own folder here, so that go away. So that we no Jesus Christ, my God. So that we can actually find it. Why is it so big as well? Oh my God. Anyway. Yeah, so what we're looking for is HID enumerate, please. Jesus Christ. See where it goes. Christ, come on. Okay. Okay, so we actually don't need to call HID init, but we will do it anyway. We do that though, right? I think we do it in here actually. Or do we not do it at all? What the fuck? HID init. Oh shit, what was it? HID underscore init. Oh no, very fucking top. Okay, cool. So that's fine. We do that. Okay. HID enumerate. Right. Enumerates. Okay. Okay, yeah, we do that. HID enumeration free. That is fine. Okay. Let's go through other shit here. Okay, so this is just the test thingy. That is fine. Now, one comment to enable retrieval page on platform different from what? Oh, okay. Well, we get the page info anyway, so that's fine. So here's the implementation, I think. Okay, libusb. Actually wonder, what if we just don't call? What if we just don't call, yeah, what if we just don't call this find devices? Like, yeah, because if we don't, then it should in theory be fine. Yeah, like it's always fine. So, yeah, let's actually tidy up all this in a second. Yeah, so I don't think it's anything wrong with our code, so that's fine. That's good at least. Yeah. So let us bring all this thing back. Yeah, this is fine. Okay, so all of this stuff can return. Yeah, this thing we don't need because, yeah, that doesn't matter anyway, so that's fine. That can go. This thing we can return. And this thing we can return. Okay. And I think that's it. Yeah, that's it here. What did we do here? Here we just added the new thing, so that's fine. Inside the H. Yeah, that is fine. Oh yeah, that's fine. Yeah. Okay. So yeah, we should be back to where we were before, where it actually works. Yep. And yeah, okay, there we go. Okay, yeah, the device is refreshing too fast are actually causing problems. So yeah, that's interesting actually. Okay. Yeah. Wait, let's just run it again. Okay. So yeah. So I wonder what can I do here? Now inside the utilities, I can do a cleanup maybe. HID exit. And then I can start it up again. I wonder. Let's see. So if we were to run out of this space here, what we can try and do is this. Now this is a bit bold, but we can do cleanup like this. And that should do the thing. Yeah. Alright, let's try that, see how that goes. Oh wait, cleanup done, exiting the program. Oh, wait, so HID exit. What does that actually do? HID exit. It shouldn't, yeah, it shouldn't like exit anything. So what the hell? Yeah, so we can exit maybe, and then we can run HID init after again. Let's try that. Wonder. But why is it exiting though? That's what I don't really understand. Maybe it's just crashing somewhere. But oh, weird. Yeah, I guess it's just crashing. Right, so what can we do? Yeah, so that's no good. Yeah, get rid of this cleanup since that did nothing. Yeah, we can do and false. So that means this loop will actually never run. So we will never get the we'll never refresh the device list as such. And yes, as you can see, the memory is staying static, and then I can, you know, do that, and the memory is like fully static. So there's no memory leaks anywhere else, so that's good. Yeah. So I guess what we can do is we can add another feature called no refresh. So it won't refresh the devices. Yeah, so we can do that. Yeah, I suppose that'll be fine in this Windows case. So here we can do this thing. Allow refresh. So here, oh yeah, shit, actually, this is gonna keep on overflowing. Fuck. Well, actually, do you know what? This is what we're gonna do. This is what we're gonna do. So here, it's gonna be this. And then we're gonna do if not allow refresh. So if refresh is not allowed, we will just yeah, we'll just continue like so. So this way this thing doesn't overflow, and then yeah, that should be fine then. All right, so allow refresh. We'll put that here as a boolean. Okay, and then we will also well, actually this will be true by default, and or fuck it. It'll be something anyway. And then here in the router here, we can put that here. Stern bool, like so. And then inside here, you can add another one here. So yeah, we can do something like this. Yeah, something simple this time. So if, so this thing, no refresh equals 0, then allow refresh equals false. Yeah, I think, yeah, that will do. So no refresh. So yeah, this will be kind of for Windows, I suppose. IT boom. Let's go into our help function here. So this will be printf, no refresh. Actually, it should probably be with both. Just going by how the rest of the stuff is. Yeah, let's do both. And let's do here. Do not refresh the device list. This causes memory leaks on Windows. Okay, like that. Okay, let's try and compile that right now. So right now it should be the default. We should get a device refresh every 10 seconds. So let's see how that works out. So it's 760 now. And did I disable it or something? Yeah, so 10 seconds. Or is this too much for 10 seconds? Huh, I think it might be too much. Let's get rid of a 0 here. Let's just do 1000. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It might be because 1 is too slow. Let's see. Interesting. Yeah, but anyway, this thing is going up slightly. Yeah. Okay, that is interesting. It actually should be 10,000. Because if I do it with 10 seconds... Say 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so first of all, there's something wrong with this refresh thing anyway. Right. Yeah, we kind of need to yeah, we kind of need to use time as such. Yeah. See, get current time in milliseconds on Linux and Windows. Really? Clock get time function. Okay, that sounds interesting. Really? Let's see. C get current milliseconds. Yeah. What the fuck? What in God's name? Okay, I guess it is just completely fucked up, but that's fine. Okay. Alright, I guess I'll have to test this out on Linux to see if it actually works. But yeah, long melee. Okay, that's fine. Okay. I guess this will go on utilities or something, yeah. So it's this, and then time.h, and then in Windows it's windows.h for all of them. Yeah, we just need to know the... Is it millisecond? Yeah, milliseconds that we're dealing with here. So that should be fine then. We'll throw that into utilities. And then, yeah, they're both returning long longs, so that's fine. We'll throw this into the Linux thingy here. Like so. And then we'll throw the Windows one into here. Okay. Oh, we already have it. Excellent. So, yeah, we don't have systime.h anywhere, so that's fine. Right, next thing, we need this kind of setup here. So we'll just copy this thing. We'll just put it here at the bottom, so why not? And yeah, so current melees, we will, yeah, we put this here. This will end like this. And here is the Linux implementation. And in Windows, here is the Windows implementation. We can just do this. It'll be easier. Oh, shit. Wait, what happened? Oh yeah, I don't know what the heck happened there, but anyway, here it is. So now we get this thing. We need to prototype this thing. So we need to put it here somewhere. Yeah, we'll put it after here. And like that. Okay, so now inside here, what we need to do is here, yeah, we actually need like, let's see, which would be a good way to do it. So yeah, actually this will be a good way to do it. So sleep, it'll actually be long thingy. So it'll be, yeah, we won't be using sleep elapsed anymore. Yeah, so this will be long current sleep, or actually it'll be like last sleep ts. It's gonna be like this, or last refresh timestamp will be like this. Yeah, and then we'll need another one called current refresh. Or actually, no, we don't need that, actually, now that I think about it. So yeah, when we do this thing, we want to do this thing instead of here. And if last refresh TS, it'll be current time milli minus last refresh TS is greater or equal to trigger interval, then we do the refresh. Okay, I think that'll work. So this should be refreshing every 10 seconds that we put down. Yeah, 10 seconds. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good, that was fairly accurate. Now, if we were to do 1, which we had an issue with, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. Right, so we fixed that issue anyway. Now, on to the next issue. Yeah, if not, allow refresh. So yeah, this is actually done. I just need to actually test it. So yeah, let's go here, and what we want to do is we want to add no refresh, like so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, yeah. So it's never going to refresh now, which is good for Windows. And you know what? It's good for the other operating systems as well. Simply because you're not really going to be unplugging and plugging devices like a bunch, unless you're testing something. So even then, if you, yeah, I don't know, anyway. Yeah, if you're testing something, oh yeah, I guess it would be, yeah, because you're, if you're like compiling the firmware, you would actually need to have it restart. But yeah, here should be fine. Yeah, as you can see, this thing is still working, and the whole thing is still working. Then I can increase my DPI, set it back to the default, and yeah, it's still working, and we're not doing anything fucked. So yeah, that's good. Okay, that is good, good indeed. So yeah, I think that's pretty much it. Oh yeah, I suppose the help also. Yeah. So you can actually change, like, yeah, it's good. Okay, so anyway. Do not refresh the device list. This causes memory leaks on Windows. Okay, cool. So that is fine. Right. So what I want to do here is yeah, I want to edit the README anyway. Yeah. So I guess in this case, you know, it'll be cooler. Yeah, it'll be cooler if this stuff was like this. Yeah. Okay. Yeah, because now if you were to look at this thing, it will be, you know, kind of in its own thing. Right. So then we'll do another one for our new feature here. You can disable refreshing the device list with these, no refresh. Oh shit. Refreshing the device list on Windows. Memory leaks slowly, so it's best to use this. It's best to use this. If you aren't disconnecting your devices often, this is fine. This won't make a big difference. Yeah, so technically it should probably be the default, but fuck it. Okay, so yeah, then when we're installing on PC, should be fine as well. Oil rate. And then lastly, we can probably do, you can print the help menu with yeah, we'll just put it here. Or yeah, let's keep it kind of the same. Yeah, so this will print the help menu. Okay, cool. Interesting that this H didn't. Hang on. Okay, weird. Anyway. Oh yeah. Kind of forgot this thing. So we have it here. We have it here. We have it here. Okay. You can enable multiple options at once, like so. And yeah, we will do so. For example, something like this will be fine. What the hell happened there? I don't know. Anyway, here it goes. So yeah, that is great. Now I wonder if I were to feed this into ChatGPT, could it generate a contents table like so? Can you generate a contents table for my markdown file that goes from my markdown file for my GitHub project? Only output the contents table in markdown form don't output anything else. Let's see if he's able to do that. Good, he did. Excellent. Right, so yeah, we'll put the contents table probably here. Yeah, that looks good. Holy shit, that looks good. So yeah, here we could just bounce to the sections, which is pretty cool. Yeah. Yeah, that is actually really good. Installing on PC, Linux, macOS, Windows. Yeah, cannot open HID device on Linux fix, routing protocol. And yeah, videos are, yeah, that's actually pretty fucking sick, if I must say so myself. Yeah, that looks pretty good. Okay. Yeah, cool. All right. So, although this kind of goes to the top, which is useless, so let us get rid of that one. Okay. That is good now. Cool. Yeah, I was actually thinking about this thing. And it's actually more accurate if it's like this. Yeah, there we go. So yeah, that's a bit more accurate. All right. So this is pretty good now. The only thing I'll need to do is I'll need to check if this sleep thing is working on Linux and Mac OS. Oh yeah, shit, actually, now that I think about it. This thing might not work on macOS, but I think it will. Will this work on Windows, Linux, and macOS? What do you mean? Well, yeah. Yeah, that's fine. And lacks support for macOS. Okay. What the fuck? Why did you say lacks support for fucking macOS, fucking donkey? Anyway, that's fine. So yeah, we will try that later on. I'll try it offline anyway, so that should be fine. Oil right. So yeah, this is pretty good. Yeah, let me just compile this thing again so that I have the latest. Oh yeah, get rid of the help. Well, okay, cool. Excellent. So yeah, that works just fine. All right, lads. Well, thank you boys for watching, and I'll see you on the next episode. Bye bye.